Just so that you're aware, today we're dealing with the unit circle and getting exact measures in for the unit circle. Whereas yesterday we used sine and cosine and found approximate values by rounding. Today you're finding exact values. And these are the values you're going to have to memorize in order to be efficient when dealing with trig. So you got your note page on the way in. On the back there's actually a place to write notes. I believe I attached, oh maybe not. Well, it's blank, so you can write notes on the back. Okay. You have your unit circle from yesterday, which you can have out in front of you. That unit circle, remember, should have only the degree measures on it right now. Okay? Borrow yours real quick. Okay, so yesterday you guys had these. You filled out that part. I just want that out in front of you. We're going to fill out a lot more in there. Okay? Thank you. But before, yeah, I'll get you a copy. Okay? But before we begin onto the unit circle, I want you to work with the people around you, and on these special right triangles, I want you to fill in the different side portions here. The special values that go for each side. If you remember back to geometry. I'm not going to help you much. I'm going to let you guys fill them in, though. Here you go. Okay, can I get your attention back up here?
I think I can already guess it.
So, we're going through these different triangles. What was this length?
X.
This is X. This is?
2x.
And?
X root 3.
Good job. Okay, same triangle, right? It's just tipped over. So this is?
2x. X. X root 3.
Okay, and the 45, 45, 90?
X.
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 And
X root 2.
X root 2. Now remember, I don't know if how much this was talked to, but you have 1, 1, 2, or 1, 2, 3. Okay, if you kind of want a quick memory thing.
Yeah,
okay.
That's how I remember it.
Okay, 1, 2, 3. The other thing to keep in mind that when you're dealing with a 30, 60, 90 triangle, a 30, 60, 90 triangle really is half of, that is one bad triangle. Well, you know what? Actually, let's do this.
Perfect.
It is half of an equilateral triangle. That's not a great equilateral, but for a sketch, we'll call this 60, that's 60, and that's 60. Okay? So if we zoom in on that equilateral triangle, and I break this in half, okay, I drop an altitude here. It gives us 90. So 60, 90, that has to mean this is 30. Okay? That, if this side is 2x, this altitude then broke this side that was 2x into x and x. And using the Pythagorean theorem, that's how we get that x root 3. Now, we're not going to go through that, but that's that 30, 60, 90. Okay? All right, so using these relationships now, let me zoom back out. So using those relationships, I want you to set your hypotenuse on each of these equal to 1 and solve for all the other sides. Okay? Exact values, please. Simplest radical form. Ready, go. Okay, can I get your attention back up here? Hey, let's see if we've got it. Here, what does x equal?
Half.
Good, yeah, you divide both sides by 2, you get x equals 1/2. Okay, right? And if x equals 1/2, then this is 1/2, and this is
0.87.
okay, or 1/2 root 3, right? We want to leave it in exact form there. Now, yeah, so what I'm going to do is I'm actually going to change that around, and you can keep it, I'm erasing a few things which you can keep on there, but we're going to write that side as root 3 over 2, the same thing as 1/2 root 3. That's how we'll see it. And I'm going to erase the x here and just write 1/2. We're transforming this into having a hypotenuse of, what's our hypotenuse here? 1. Okay. So when we have a hypotenuse of 1, this side is 1/2, this side is root 3 over 2. Here, the hypotenuse is also 1. It's just we've tipped the triangle a different way. Okay? That makes our x, it's the same as this over here, which is 1/2. And this is root 3 over 2. Okay, so how many are with me so far? All right, good. Let's move on to the next piece here. Going over here, we divide both sides by root 2. You end up with x equals 1 over root 2, which then we can't have a radical in the denominator. We've got to rationalize it. So we multiply both sides by, or this side by root 2 over root 2 to give us 1 root 2 over 2. So here, when the hypotenuse is 1, x is equal to 1 root 2 over 2. We solved for x here. It gives us 1 root 2 over 2. And makes this side also equal 1 root 2 over 2. Okay? So we kind of clean this up a little. Call that root 2 over 2. Call that root 2 over 2. And call this side, what was this side?
1.
1. All right? And erase all that. You don't have to erase it. You keep it in your notes there. But just so I can clean it up and we can see it, that is 1. Okay. How does this relate to what you did yesterday? Focusing primarily on this quadrant. Talk with your neighbor about it. Okay.
Why?
Here we go.
Why do you pay for half of those?
All right.
Why?
Right back here. Everyone's attention back up here, please. Very good. So, hopefully we recognize that these triangles right here, this 60 degree, this angle that goes up, this is if we drop an altitude. That gives us that 60 degree and 30 degree and 90 degree. It gives us this triangle right here. Right? So if I can find this point, the coordinates of this point using these measures, then on my triangle, I found the coordinates of this point here. So this length is 1/2, which makes this on the x-axis. How far, if we moved over 1/2, what's this coordinate? It's 1/2. So our x-coordinate is 1/2. Our y-coordinate, if we start here and go up root 3 over 2, right there we're at root 3 over 2. Okay, so that would mean on our unit circle, the coordinates of a 60 degree angle are 1/2 root 3 over 2. Okay.
Should we write that down?
I would write that on my unit circle. Yeah. Okay, I want you to do the same thing for 45 and the 30 degree triangle. Put the coordinates next to them. Use your triangles here to help you out. I mean that point and that point. Here we go. Hey, what's the coordinates of this point?
Root 3 over 2, comma, 1/2.
Okay, what's the coordinates of this point?
Root 2 over 2 and root 2 over 2.
All right. It sounds like we have it, right? Move on here. We duplicate that 30, 60, 90 triangle that's been tipped over. Put in our right angle there. And our 30 degree was root 3 over 2, 1/2. So we're going to make this root 3 over 2, 1/2. Okay? And our 45, 45, 90, root 2 over 2, root 2 over 2. There, you've got it. All right? So we've got our coordinates there.
All you have to do is set
Exact values.
So like if we're trying to find the different values of a triangle with these angles, all we have to do is set a proportion, basically.
Yeah, I think, if I'm understanding your question right. Hey, so we have our 30 degree, our 45 degree, and our 60 degree. Okay, got our different triangles there. Hey, right now what I want you to do is I want you to fill out the exact values for every other measure on the unit circle using those measures. The exact coordinates, excuse me, for every other measure, angle measure we have on there.
Do we have to draw the line?
Let's get these on here. So this coordinate at 0 is?
That is 1, 0.
1, 0. And we got all these. How about 90?
0, 1.
Yeah, 0, 1.
Do you know what?
Right? Hey, by the way, which means if this is 1, 0 and this is 0, 1, that means this length is a length of 1 and that length is a length of 1. These lengths in here can never be
more than 1.
Yeah.
Sine and cosine
They always have.
They have to be in between -1 and 1.
Okay. Yeah, they have to be between, this length has to be between 0 and 1. It can't be any greater than 1. And the values for sine and cosine are going to be between -1 and 1. Okay?
That means the unit circle has a diameter of 2.
Unit circle has a diameter of 2. Good. Good. We have a radius of 1. So, how about this right here?
That's
-1/2 and 3.
Okay, so -1/2, that means this quadrant right here, right?
Is positive, positive.
From yesterday, that's a positive, positive. This one is
Negative, positive.
negative, positive. Here,
Negative, negative.
Squared, negative. And
Negative,
positive, negative.
Positive, negative. What am I talking about? It's the other winky face. Come on.
good. Yeah, so our coordinates should look like that. We're dealing with it, right? So this value right here, if I'm drifting across, it has the same y coordinate. It's a reflection of 60 degrees over. Okay, so the y is going to stay the same. The x changes. It becomes negative. So from 1/2, this is 1/2. So this is still a length of 1/2 over, but we're at -1/2 as a coordinate. Samir.
You don't need a calculator once you've solved the first quadrant.
You shouldn't have to. You're right.
So you didn't really need
All right, how about here?
in the first place.
Negative root 2 over 2. And root 2 over 2.
Here?
Negative root 3 over 2 and 1/2.
Here.
Well, -1, 0.
Hey, I want everyone. What do we have here?
Negative root 2 over 2 and -1/2.
And then a rod. And it.
Okay, so they keep repeating themselves, right? Make sure I don't make any mistakes, please. Thank you. You alright? Yeah, seriously. Man.
It's a daily thing. We can can't time when Nicole will be tardy to science though.
Everyone's checking me, right?
Yep.
Well, sort of.
It is kind of blurry. It'd be nice to actually get a document camera that focuses over there. Yeah, that kind of did it.
Exactly.
And what's that?
Yeah, you wrote that.
I know, but it's 360. You got to write it up. You don't want to cheat 360, man. All right. Hey, we got it? Now, on your test, your quiz, throughout the chapter, whenever you're studying trig, you should have these memorized. On your test and quiz, I'm going to give you a blank unit circle and say, fill it out.
Well, that's not that fun.
Yeah, you could.
Well, it's not really memorizing. You just refigure it out.
You could just refigure it out. You could memorize. You could learn the pattern. You could. Good.
Good, wing it. This is why we're friends.
Oh man, that was awesome.
So funny.
Whoa, that's great. Oh, there's a pattern. Whoa.
You didn't need to drop it.
That's amazing.
Well, I did it anyways.
You didn't get it anyways, too.
That's amazing.
Cool.
Whoever made this is a genius.
Some of you are catching on. Some of you are just yakking up a storm.
Whoa!
Can we fill it out like that instead of having to do the reduced form?
Yeah.
Am I allowed to use my calculator program that I put on there? Like, it's cheating. I use the program, but
Yeah, probably wouldn't let you use a graphing calculator.
Oh, it's the same thing.
You really need to memorize these. I have tried to give you a hint on a quick and easy way to memorize them. For those of you that have been paying attention to what I'm writing versus... No, you can't write it like that.
Darn it.
However, that does help you actually if you look at this and know that this has a length of 1, therefore this coordinate is 1, 0. Well, root 4 over 2
Is 2 over 2.
Root 4 over 2 is the same thing. Root 4 over 2 is the same thing as 2 over 2. So we call that 2 over 2, which is 1. And this is the same thing as
0 over 2.
0 over 2, which is
0.
0. Root 3 over 2 is still root 3 over 2. And root 1 is 1. So this is the same thing as root 3 over 2, 1/2. So once you write it out like that, you could just simplify it. That's already simplified. This once again is 1, so this is equal to 1/2 and root 3 over 2. And this one, that's 0. This is 2, so we get 0 and 2 over 2, which is 1. All right, and you can continue. I mean, root 4, root 3, root 2, root 1, root 0, root -1, or negative root 1, negative root 2, negative.
That's
Okay,
not possible.
you can keep doing it, or you can just reflect these points from there. Okay, how many see the pattern? Woo. Got it?
Yeah.
Okay, I'm going to have you guys summarize that in your notes right now while I hand out the next page that you need. Okay? Hope everyone summarized this in your notes. For those of you who have not summarized this pattern in your notes, please remember you're in 9-2. Okay? You have a big chapter ahead of you, and we haven't even started graphing by hand. All right? What seems easy now won't be easy when you're trying to recall it later or next year. Have good notes for yourself. Hey, I want you to look at the sheet that I just handed out. I do not want you to look at your notes at all. I want you to flip the other unit circle over that you filled out. And right now I want you to duplicate all measurements and coordinates that you've learned onto this unit circle.
Do you want it to be with the pattern or without?
Well, if you use the pattern to do it, you always have to simplify.
Okay, I just want
Okay?
the pattern.
So, duplicate it without looking at your notes. Do it on your own without looking at your neighbor's paper, without talking to your neighbor. Here we go. Degrees and the exact coordinates.
constantly axes.
Okay,
against bow ties.
so hopefully you compared it. You're doing well. Some of you didn't quite finish yet. That's okay. The point of having that was to see if you could actually go through how far you could get and go through and duplicate it on your own. We're going to actually add radian measures to that here in a while. Okay, especially because some of you are going to be gone tomorrow. But your assignment today is to use your unit circle and use the special right triangles, how we filled out the exact coordinates using those special right triangles, and the sine and cosine functions to find the coordinates of each of those angles. So we know that looking at our unit circle, this value right here, this root 3 over 2, hey, actually, let's look at this one. This root 3 over 2 represents this length. That's your cosine value. So cosine of 30 should give you root 3 over 2. If you figured out the decimal form of that, you put that in your calculator, you should get that. The sine value is your 1/2. Sine 30 is equal to 0.5. So if you put sine 30 into your calculator, you're going to get 0.5. Okay? So you're giving me the exact values of these measurements, of these measured angles here within the unit circle. Okay?
So it's like sine 1.3.
No, you're just giving me the coordinates. So 30 would be root 3 over 2, 1/2. That's all I want. I want an exact value. Any questions there?
Oh,
Hey, when you turn it over, go ahead.
That looks like 1.3 degrees. Doesn't look like 30.
Oh, that's number 1.
Oh.
Okay. Hey, on the other side, note that some of these are greater than 360. We get some negative angles, but each of them should fall at one of our special angles in the unit circle. So this is for your reference. You don't have to fill it out. It's just so that you can quickly go through and figure out where negative 300 is. You know, starting in standard and moving 300 degrees.
Cotangents.
Not cotangents, no.
The-
They're still sine and cosine. Right? So if we
Yeah,
go...
no, but the cotangents, are like we find it by using the fact that they're cotangent of the other.
No. This is just... You mean coterminal?
Yeah.
Coterminal. Yeah, they terminate at the same spot as another. Correct. Yeah. Okay, so we can go negative 300 and figure out where that terminates, and it will be coterminal with one of our positive angles that we've already graphed here. Okay? All right. Very good. Here in about 8 minutes, we're going to go through some radian stuff. All right? So get as far as you can in that time.
Zach.
Okay, so talking about radian measures, especially for those of you that are going to be gone tomorrow, I put the video that we're watching tomorrow in class, I put it on the website so you can select it and watch it. It'll give you a good conceptual understanding of what a radian is. Okay, right now I'm just going through how to show the measurements on the unit circle and how to quickly duplicate them. But I want you to watch that video. You can watch it with all your friends. Like, amazing. Okay. How many are going to be gone tomorrow? You guys can like huddle up, you know, over there and be watching the...
Dr. Who.
Awesome. Okay. All right. And for those of you that aren't going to be gone tomorrow, you know, on the weekend you can share it with your family. Have a family movie night. It'll be fun. Okay.
That's 1/2 radian.
So,
that's 1 radian. That's...
I'm not going to go into what a radian actually is. I'm just going to explain how to find the measures, and I'll tell you that it's another way of measuring angles. Okay? We're dealing with radians versus, instead of using degrees, we're using radians. So when your calculator says rad, it doesn't mean it's awesome. It means it's in radian mode. Okay? Okay? So, yeah, they are awesome. Okay? So right here, they've actually marked a few radians. At 0 degrees, you're at 0 radians. At 180 degrees, you're at pi radians. Okay? So that's what that little pi symbol's over there for. Now that helps us out. If we can remember that at 180 degrees, that's pi radians, well then think about 90. 90 is half of 180.
Half radian.
So this is pi over 2 radians. Okay, and if you go back to, say, 45, 45 is what part of 180?
fourth.
Yeah, it's a fourth. It's a half of a half, right? It's a quarter. So this is a quarter. 1/4 of pi. So pi over 4 radians. Okay? And so from there, we could actually fill in all of our 45s. You go 1/4. So we're at 0 quarters, 1/4, 2 quarters, which is pi over 2. This is 3 quarters. So 3 pi over 4 radians. This is 4 quarters, or 1 pi. This over here is
5
Yeah, this is 5 pi
over 4.
over 4 radians. Keep going. 6 pi over 4 radians. Also known as, we have 6 pi over 4, that's the same as 3 pi over 2, and we always want to reduce just like we did in our coordinates here. So we'll reduce that. 3 pi over 2, so 6 pi over 4, 7 pi over 4.
Oh, shoot.
Okay?
Yeah, I did that.
And then 360 is,
2 pi.
yeah, it's 8 pi over 4, or 2 pi radians. Okay? All right, so we filled in a good chunk. Now we have to do the 30s. Well, if you think of 180, 30 degrees is what part of 180?
1/3.
Third.
How many 30s go into 180?
6.
6. Okay, so it's
Right.
1/6. So this is pi over 6. So 0 pi over 6, 1 pi over 6. 60 is 2 pi over 6, or, yeah, pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3. 5 pi over 6. And 6 pi over 6, or pi. 7 pi over 6. 8 pi over 6. Is that reduced to? 4 pi over 3. Okay. 5 pi over 6, or excuse me, 8 pi over 6, 9 pi over 6, which is 3 pi over 2. 10 pi over 6. Or 5 pi over 3. And 11 pi over 6. And then 12 pi over 6, which is 2 pi. Okay, so now you have your complete unit circle. You need to memorize all those parts. Okay? Now, I've given you hints on how to do it, right? I mean, if we could remember 180 is pi, that's 1 pi over 6, 2 pi over 6, 3. And, you know, you keep going around, right? All right. Any questions? Tomorrow we'll go through actual conceptual understanding of radians. All right, very good. Those of you who are going to be gone for the band trip, have fun. Don't forget about us. You can watch the video lesson and remember. Oh, we don't have a video lesson tomorrow. Sorry. That's sad.